Okay. First of all, I want to let everybody know that next month we have Scott Honaker coming back, and we're going to be doing, or actually, he's going to be doing a presentation on radio direction finding. I actually asked him to if he could do this month, but he said he's in the process of revamping it and asked if he could do it next month. So I decided to fill in with a short presentation that I had prepared. And I'm still looking at you, Rich. So do we need to switch? Do you need to give me your authority to?
If you switch to speaker view up in the top right corner, it will switch it to it's just the person talking.
Yep, and that's what I'm in. So I'm going to see if I can share my. I had this problem the other day with. It doesn't seem to want to let me share my screen. You guys aren't seeing it yet, right?
No, we're not seeing anything. Yeah, you have to, I think you found it though, the screen share icon at the bottom you have to click on.
Yeah, I clicked on that and it's for some reason not letting me do it.
If you're made a co-host, it makes it easier.
Yeah, it's probably. Did you make me a co-host, Rich?
Let's see. I don't think we made you a co-host. I don't know where I'd find that on the screen to switch it.
Hey, Rich, for sure, under your security session settings, do you have participants can share screen?
Yeah, share screen is checked. Okay, I went into like cancel participant and then I canceled that and I guess that let you in.
Yeah, we had this problem once before with my Mac not allowing us to share or.
Yeah, your screen share was up there momentarily, then it went away.
That was mine.
Yeah. Hey, Jeff, if you've got that as a document, send it to Mel or to Dell or one of them and let them run it for you while you talk.
Yeah, the problem is the size of it, you know. It would take until Tuesday next week for them to receive it. Because I have a lot of pictures in it. Oh man, why is this not working?
So let me understand, Dell, was it correct that you were sharing your screen? So in other words, this must be a problem at Jeff's end?
Right. That's what I was testing. Because the share button came up for me just fine and it shared obviously 2 or 3 windows. There you go, Jeff.
That's yours. Yeah.
Finally
Jeff.
got it. Okay. Let me go into slideshow then. There we go. Yeah, it was definitely Rick on my end. For some reason, it was wanting me to give permissions. Okay, so anyway, sorry about the delay, everyone. What I wanted to do was to cover a whole bunch of stuff that we all should have, could have, and will find useful. So the list is right there. That isn't the complete list. I have some other stuff I'm going to show everybody at the end of it anyway, but obviously we're going to start with multimeters and end up with the HP RF test sets that Rick gave us a presentation on a few months back. And we're going to try and cover everything in between. So went too fast. So multimeters was the first thing. Obviously multimeters we can use to check continuity. Is a wire making contact or is there a short? It's useful for checking antennas and or coax. Some people are not that proficient at soldering. So it's always a good idea to check before you, once you've done a PL259 or SO239, whatever, and make sure that you don't have a short or that you actually do have contact, both on the braid and on the inner conductor. Some of them are auto ranging, like the first one. You don't really have to do a heck of a lot with it, other than take the 2 probes and test something. Others are like the second one where you have to select DC voltage, AC voltage, ohms, etc. And then there are others like the Fluke that's off to the right there, which is a desktop rather than a handheld. So they come in a variety of looks and types. And obviously they can help you measure resistance from a few ohms to millions of ohms. They're great for checking circuits, open or short circuit resistors, and as I said before, continuity. And they are both digital and like the Simpson analog. That's a fairly old analog one, but we some of us still have things like that. And moving on, you can use them to measure voltage, and here's a little circuit that shows you where you'd be measuring voltage across a resistor. So you can determine the voltage drop through R3, the 200 ohm resistor, and that kind of thing. And if you've got a 9-volt battery that has registered 1.7 volts like that other one, throw it away. And moving on, you can check current with it. And to check current, you put it in series with the load, and you can measure how many amps, whatever the load happens to be, whether it's a light bulb or something. You can measure the current that's going through the system. And of course, it will also tell you what size of wire that you're going to need to, for example, lighting circuits in your house. You're required to have 14 gauge wire, and power circuits in your house are required to have 12 gauge. And many older houses have combinations of lights and power on the same circuit, and many of them are 14 gauge. So if you are revamping your Radio Shack, then good idea to look and make sure that you've got 12 amp circuits and probably do as I did and have a dedicated circuit run into the room, plus a 240 volt circuit run into the room as well. A lot of the multimeters have got also a transistor tester built into them, like this one. You can put in NPN and PNP transistors, which is great if you happen to know whether it is an NPN or a PNP. But I'll talk about some other things that make life even simpler. But anyway, this gives you an idea how you can use them to determine both the NPN or PNP type transistors. And moving along, these are the devices that I was talking about. There are many different varieties of these. I've got 2 or 3 of them. I forget exactly how many now. But anyway, you can plug a device into that socket, and you can see they've got numbers 1, 2, 3 there, and they will tell you, like the one on the far left is a MOSFET, and the one on the far right is a TRIAC, and the one in the middle is a PNP device. So they'll tell you not only what the type of device is, but they tell you what the actual pin numbers are. So you look at number 1, 2, 3, and it will tell you, for example, on the MOSFET, the number 1's the gate, 2 is the source, and 3 is the drain, and so on with the other devices. So the one in the middle, the 1 is the emitter, 2 is the base, and 3 is the collector. So they tell you not only what the device is, as you can see with the one in the middle, it tells you the HFE, which is the gain of the transistor at that particular current and millivolts, the number of voltage across it. So it gives you an idea of what that particular transistor is capable of, that kind of thing. So they tell you more than the multimeter that has the socket. So that was the point there. There are a lot of other devices like capacitance testers. Obviously, you can see the 3 that I happened to take or snatch pictures of. They tell you the different, the value of the capacitance. The one on the right there, you have to select the range of capacitance, and the one in the middle is sort of auto ranging. A lot of these devices are skeletal, like the one in the middle. You can put them inside a box of some kind if you want to, but you can buy a kit like this and you can actually build these things yourself, and they are not that expensive. And comparing them with other devices, they're so close that you really don't need to worry about how accurate they are. They're accurate enough. There are specialty capacitance testers. I've got one. I didn't take a photograph of it, but they're ESR, which what that will tell you is the internal resistance of the capacitor, and that will indicate when it needs to be changed. So if the capacitor is lossy, then it's time to change it. This obviously is particularly of interest if you are in the business of, or the hobby of changing, buying used equipment, old radios, old power supplies. So one of these ESR capacitance testers is really, really good to check any of the capacitors in any of the circuitry to find out if they're any good. And there are also inductance testers. And the inductance testers, obviously, if you've got like the one in the middle, there's an unknown little coil toroid wrapped with some wire, and it'll tell you what the value in microhenries. Some of them, and that one's sort of auto operating. The one on the far right, you have to select the range, and the one on the far left is the desktop version of supposedly more accurate than the other ones, but who knows. Some of them do both functions, like both capacitance and inductance. So like the one on the left is capable of doing both. So it's 2 meters in one. And then we get to power, watt meters, SWR meters, that kind of stuff. The one that is on the left, the SW102, goes by a number of names. Mine's a Surecom. It's not as the picture is. It says NESECU. Mine says Surecom on it, but it's the exact same device. And you can see that it tells you the power out. In this case, it's 2.9 watts. It tells you the VSWR is 1.02. It tells you the forward and reverse power on the lower level. So 2.900 for forward, 0.02 for reverse. And it also tells you the frequency that you're testing, which is in this case 143.224. So I use mine daily, at least daily. Right now I've been doing a lot of checking of radios for scope. We bought 10 TK790s. So I've been checking the power out and the SWR on all of them, to make sure that they're functioning as they should. And then, of course, over on the right, we've got the Daiwa CN801, which is a HF device for those folks. Like, I actually have one of those. So it tells you forward and reflected power on HF frequencies. I have a couple of other UHF, VHF, and also a couple of other HF devices that tell me power. And in fact, for example, I go from my 7300 into one of a power meter like the Daiwa, and then I go from that to the amplifier, and from the amplifier to the Daiwa, to the antenna tuner, and then to the Daiwa. So I can check both the power out of my 7300 into the amplifier and the power out of the amplifier going to the antenna. So it's often useful to have multiple of these tools. Moving along, if you're in the game of making antennas, there's a device called a signal strength meter that is a really good thing to have. You can make an antenna, feed a low-level signal into it, and then walk around your house or around the outside of your house and try and get some readings to determine how well that antenna is performing in any given direction. Or as in my case, I have the hex beam, which is in one direction, it's sort of shooting over the top of the house, and the other directions it's not. And I obviously wanted to observe and see if the house was actually having some effect, and it had negligible effect on the output level. So I'd walked around the house to check that out. So again, another useful tool to have. And then I did that presentation earlier on antenna analyzers. So we won't belabor antenna analyzers very much, but other than this is how it can help you, you know, determining resonant frequency of an antenna, help you tuning the antenna, reducing the SWR, increasing return loss, that kind of thing. And also determining one of the things you can do, for example, with that rig expert, is you could determine velocity factor and the length of a piece of coax. So if you know the velocity factor, you can determine the length of the coax. If you know the length of the coax, you can determine the velocity factor, that kind of thing. You can also determine inductance and capacitance or reactance of a transmission system. So that is convenient and helpful. Another tool that I have, actually a couple of, one is audio frequencies only, and the other is RF frequencies. And of course, they can help you with determining, for example, is a speaker working? Is it distorted? You can just feed a signal generator into a speaker and determine whether or not it sounds distorted on a pure tone. And most of them you can generate different types of signals, sine waves, which would be a nice pure tone, square waves having lots and lots and lots of harmonics, or triangular waves, that kind of thing. So they're very useful for lining radios and also just checking, like I said, speakers. And then a frequency counter. I've got a couple of these. They're also good for checking, is your equipment putting out the right frequency? Is an oscillator oscillating at the right frequency? And again, the one I've got is the one on the right. And they're fairly accurate. Like most things from China, you can forget about the last digit or two. It really is not that important. And then I've got a number of these devices as well. These are, I call them frequency counters, and I should have CTCSS up there. The one in the middle I've got Surecom, and I've also got one that's very similar to the one on the right. And what they will do is they will tell you if you're close to a transmitter. So they're really useful for testing. Have I put in the right tone and frequency into my handheld if you're programming them? So I've, like I said, I've got a couple of them, and you can check and make sure you get the right frequency and tone put in there. Just hold them fairly close, you know, one in each hand kind of thing, and it will tell you whether or not you've programmed your radio correctly. So again, a real useful tool. And then we get to the oscilloscope, which is probably one of the things that I think everybody should have, but that's just me. You can visualize, you know, whether you have a true sine wave or not. In fact, just the other day, I was over at Greg Pruce's house, and he's got a couple of inverters, and one of them said true sine wave inverter, and the other one wasn't so specific. It just said sine wave inverter. And we took a look. He has bought a scope at one of the Hamfests, and I've been teaching him how to use it. So we were checking to see whether or not his inverters. Now that's something that, you know, all of us, if we're going to do emergency stuff out in the field, we might be involved using an inverter and a battery and stuff. So we checked his too. And in fact, the device that said it was a true sine wave inverter actually did have a true sine wave, and it looked like the one on the right. All of these other things that you're looking at are, things that, with the exception of the quake and the round PM, it's what an inverter could look like. Sometimes they look like the absine half, and some of the other ones. So sometimes they even have steps in them, something similar to the one that's marked sine ver. In fact, his other one looked far more like that than a true sine wave. So again, a very useful tool for looking for measuring amplitude. You can measure the amplitude of a signal, the wavelength between the peaks, and you can also look for distortion in a signal. You can do frequency domain analysis and phase relationships, and tracing signals in general through excuse me, through circuits. So for example, here we are, we've got the most simple circuit that you might want to trace. It's a power supply, and you've got your AC mains going in, hopefully looking like a sine wave. You've got it going through a rectifier, obviously coming from a transformer first, but through a rectifier, and it's going to look like that second series of humps. And then you have a smoothing capacitor, and it should look something like that last image where you've got those very slight bumps in it. So that's, one of the things you can do to check power supplies. And that those series of small humps in the third part of that is called ripple, and it's something that is indicative of either if it's greater than the specification that the manufacturer has, then it's indicative of poor design, or you've got smoothing capacitors that are on their way out. The other circuit is a phase inverter circuit, a splitter. So you have a signal going in that's a sine wave, and you're getting one out that's in the same phase and one out that's in the opposite phase. So you can check at those various points and make sure that that circuit's working as it should. So it's just a really useful tool for tracing signals. And whoops, overshow it. So for example, up in the top left-hand corner, we've got a picture of heterodyne and hum on a sound, and noise over on the far right, and a series of pulses on the right, a little bit lower. So you can check pulses, and then the square wave on the bottom at the far right, you can see there's a little bit of noise on it, so you can determine what the amplitude of the noise is relative to the signal, and determine, is this going to mess up my circuitry? And if you look at the picture of the actual scope itself, the BK Precision 2160, you can see there that channel 1 set for 0.1 volts. So we're actually looking at 2 squares, 0.2 of a volt, and it's a 1 kilohertz square wave. So it you could tell exactly what's going on exactly that quickly. And that's an analog one, and these are digital ones, digital oscilloscopes, and they all have the ability. You can see the one on the left has multiple traces. Analog ones have multiple traces as well, but the digital ones have the ability to do like a screen capture and save it so that you can store it, file it, you can even output it and file it off, print it, that kind of thing. So you can go back and use it as a reference later on. But other than that,
Just a note on those, Jeff. Just a note.
Sorry?
Oh, just a note on oscilloscopes. The prices of the new digital storage oscilloscopes has dropped to where it's just crazy not to have one.
Yeah, I agree. Yeah, I mean, those Regals are, ridiculously cheap, and it's a 4-channel scope as well. So, it's, I think Peter got himself an analog one. I've got analog ones. I don't have a digital one, but it's on my list.
Yeah,
Yeah.
I bought a Siglent 2-channel, 200 megahertz bandwidth scope for $3 something.
Yeah.
Great, works really, really great.
Yeah, they are just ridiculously cheap now, and really, really useful, as you know. Just moving along, another thing that is pretty useful is an SDR dongle or spectrum display. You can view an entire band of frequencies and get waterfalls. I've got a picture coming up, but you could. One of the things I found was that the Icon 9700 has the ability to expand its SDR screen. It's not a dongle, but it's a complete radio. But you can expand the screen, and you can tell when somebody's carrier signal is off frequency. I noticed, for example, a lot of the repeaters in the area are 20, 50, 100 hertz off of the frequency that they're actually supposed to be on. Not a problem, really, when it comes down to it, but it's just an sort of nice observation. In fact, Rick and I did a bunch of testing comparing his equipment with my equipment, and we found we were like 30 hertz off or difference, and which is negligible. And so if either one of us were to tell somebody that they're a couple hundred hertz off frequency, then they're going to be a couple hundred hertz off frequency. So that was just an interesting observation that Rick and I played around with a while back. You can also, on the 7300, you can also, or other radios similar to that, you can tell when somebody is transmitting and creating splatter, because you get if you go to the expand it to the 25K, I think that's the width of plus or minus 25K. You actually get a 3K column on somebody that's got a pure, clean signal. And if there's anything outside of that, splattering outside of that 3K column of signal, then it's because they're generating garbage, with overdriving their amplifier or something like that and creating splatter. The other cool thing about the dongles is you can listen to all kinds of stuff, like buses and fire and commercial, even broadcasts. So and I've got the bottom two on the left, and they both seem to work about the same. This is what you get out of them, what it looks like. If you're using, I use Air Spy software, that's what it's called, with the dongles, and you get a screen that looks something like this. And upper part is the spectrum and what's happening right now. The middle section is what has happened over a short period of time. So I don't remember exactly this particular window, but it's what has happened over a period of time. And then you've got the IF spectrum and audio spectrum, which you can turn on and off if you're not interested in looking at that aspect of it. If anybody's interested in learning more about SDR stuff, there's a series of 3 lectures by Dave Kennett, and that link is to the first one. And it's really good. It covers sort of basics on the first one. I'm probably going to get this the wrong way around, but it's software on the second one and hardware on the third one. I think that's the way it was. So it's a good place to, if you're interested in SDR, to go check it out. Spectrum analyzers are great for determining resonant frequencies and also viewing harmonics of frequencies that are generated, seeing if transmissions are out of band and that kind of thing. And then we get to the Motorola service monitors, and they comprise of basically many of the other tools that I've talked about, because they have an oscilloscope section, a spectrum analyzer, a frequency counter, all the other stuff that I was talking about. You can measure voltages, duration, wavelength, return loss, frequency, that kind of thing. And then we get to Rick's piece of equipment that he gave us a demonstration on, which I think is the bee's knees. And it does 22 individual, it replaces 22 other pieces of equipment. So you can do virtually everything I previously mentioned with that. And here's the some of the things you can do with it. I'm not going to bother to read all that list off, but anyway, you can see it just does a whole bunch of stuff. And if you remember Rick's presentation, then you will know a lot more than what's there. Anyway, this is by no means everything an amateur could collect or should have in their arsenal of equipment. Couple of other things, continuity tester, an ammeter, voltmeter, and a Morse code reader. And what I want to do is click to exit presentation. That's what I want to do. So I guess I need to stop sharing, because what I want to do. All right, what I wanted to do was to show you some of the other tools. So, for example, this is an analog UHF VHF SWR power meter that I've got, as well as the Surecom one. So they're very handy, useful things. I mentioned the ammeter, voltmeter. This is a little inline device. You can see it's got Andersons on both ends, and you just put it between your battery and your power source and your load, your radio, whatever, and it will tell you the voltage and current that is being used. So that's another device. This is a handy tool if you're running in. It checks your AC power outlets and things. Make sure you've got power there. It's another tool, handy tool to have. This is another really interesting tool that people might want to have. Hopefully you can see the, okay, yeah. It's actually a giving a reading of the audio level. So it's a sound level meter, and you can see it's moving up and down depending on whether it's hearing my voice or not. But if you want to check the output of a speaker or something, or find out how deaf you are, it's a useful tool. And then one of the, I just wanted to show you, I've got a transistor in there, just wanted to show everyone what this looks like. It says it's testing, and now you can see it came up and said that it's the NPN transistor gives you all the information. And you see how small they are. They're very, very handy tools. Another, I mentioned the skeletal things here. If I turn on the power, hopefully you're going to be able to see this. Maybe it's too bright. I guess so. Anyway, I put a capacitor here, an inductor here, and an electrolytic capacitor here. And this device has got capacitance, so it will give you the value of that capacitor by pushing that button. If you push this one, it will give us the value of the inductor that's right there, and it says 654 microhenries. The capacitor was 37,000 picofarads. The last connector here is frequency. You can also measure frequency with it. And then these two are for electrolytic capacitors, as is this connector right here. So I've got a small electrolytic in there, and if I push that button, it tells me it's 6 microfarads. If we put a bigger one in there, we push that button, and this guy is the power, and it runs off of a 9-volt battery. So, you know, another inexpensive, useful tool.
Jeff, comment?
Yeah, sure, go ahead.
Yeah, the inline power meter that you showed with the Anderson power poles on it. A
Yeah,
second really valuable use for that is measuring the output of solar panels. And so
yes.
you can use it in aiming, because it'll show you how much power is going into your battery, and you can use it for aiming them to optimize the sunlight that's hitting it, and also test just how efficient they are too.
Yep, exactly. And then, by the way, this one measures up to 200 amps. Another interesting device that was a recent purchase. This is a bug sniffer. A friend of my wife thought that somebody had put bugs. She had some roommates, thought she had put some bugs in her house because for some reason or other, this person who she kicked out knew something that she wasn't supposed to know, or like she must have overheard a conversation or something. Well, I went around her house with this, with my oscilloscope, with other devices. And the interesting thing is I was able to find her Wi-Fi system that she had in the house. We turned it off. You were able to find all kinds of RF transmission devices, and including her cell phone. She turned the cell phone, started, her cell phone was, the screen of it was black. And the moment she touched the screen and it became alive, this thing lit up and told me that it was transmitting. So it's kind of a nerdy thing, but kind of fun at the same time. Oh, one last one, yeah. This is something, it's a thermocouple or whatever you want to call it. You can attach this to, or tape it to a heat sink, and you can measure the temperature of the device. So if you're testing, power supply to death or something, then this is a handy, useful device. And I can see that the temperatures seems to be going up or down, actually. But anyway, so another handy tool. And with that, I'm done.